Let's do a problem from your lab assignment. This is from section 11.2. It's problem number 4. Determine whether the series is convergent or divergent. If it converges, find its sum. And the series is a series from k going from 1 to infinity of k times k plus 13 divided by k squared plus 14. For the series, this thing, which is, they ended up multiplying the numerator and denominator out, so we have k squared plus 13k, and the denominator foils to k squared plus 28k plus 196. They want us to take the limit of this thing. If you take the limit of this thing, you can do a variety of things. You can divide by the highest power of k in the numerator and in the denominator, and then take the limit, or you can take L'Hopital's rule a couple of times. But either case, your limit is going to be the coefficient of k, since they have the same powers. The polynomials have the same powers in numerator and denominator. You can just take a look at the coefficients of the numerator divided by the coefficient of the denominator, and that's going to equal to 1. And I think what they're trying to get at in this problem is that the test of divergence in your textbook says that if you take the limit as n goes to infinity, not the series itself, but the sequence of numbers that goes into the series, and it's not equal to 0 or it does not exist, then the series is divergent. Now, if it's equal to 0, it does not mean it converges. So that's we have to be careful about this test for divergence. So maybe it might be worth putting if this limit does equal to 0, then there is no conclusion about the series that we're talking about. So the test of divergence is a pretty simple test, but most of the time it's not going to give you a conclusion. In this particular scenario, however, our limit does not equal to 0, so we can just say it diverges. Okay? All right, hope that helps.